Okay, let's do another example, finding where this function is increasing or decreasing and finding any local maxes or mins. All right, so that's my y. So y prime is going to be 4/3 x to the 4/3 minus 1 is 1/3. Then this will be 4/3 x to the 2/3 minus 1 is negative 1/3. Now, I want to factor this. I can factor out 4/3, and I can also factor out x to the lower power here. The same way if you had 3x cubed plus 3x squared, you'd factor out the lower power. Doing the same thing down here. Factoring out the lower power, which is x to the negative 1/3. And what's left inside is 4, or not 4, that was factored out. This is going to be x to the 2/3 minus 1. And I'm going to rewrite this again, making this x to the 2/3 minus 1 on top. Now let's see, the 4/3, the 4 can go on top, the 3 goes on bottom, and x to the 1/3 goes on the bottom as well. So our derivative here has both a numerator and a denominator. So we need to set both equal to 0. Setting the numerator equal to 0, that gives me, let's see, x to the 2/3 minus 1. I left off parentheses here. This gives me x to the 2/3 equals 1, so x is positive or negative 1. Let me do that. Let me do that a little better. You've got 4 times x to the 2/3 minus 1 equals 0. So divide both sides by 4. You get x to the 2/3 minus 1 is 0. All right. Move the 1 to the other side. Now, if you cube both sides of this, you're left with x squared equals 1. So that gives you plus or minus 1. All right. And if you set the denominator equal to 0, you just get x equals 0. Now notice at plus or minus 1, the derivative is 0. At 0, the derivative is undefined. So we've got 3 critical numbers here. I'm out of space. I'm going to come over here to the side. And I'm going to put in negative 1, 0, and 1, because those are my critical numbers. And my test values, I could pick, say, a half, 2, negative 2, and negative 1/2. But tell you what, let's do. Let's cheat a little bit. I'm going to put in f prime, and I'm going to put in f for my chart here. Let's just get Desmos to graph this for us. Let's see. Let's get them both up here at the same time. This is unfortunate. Well, here's what I can do. I can move this down a bit. And all right, that's kind of crammed in there, but that'll work. Let's put our function in. We've already got it written here. I'm going to change the name of this to f of x. All right, and if we graph this, check out what it looks like. It's got this sort of shape. And if I highlight it, notice it gives me, it shows us there, that's at x equals negative 1, that's at x equals 1, and that's at 0. So if we were to pick the test values, what it would show us is, notice here, between I'm gonna do all of this on Desmos here. X equals 0, x equals -1, x equals 1. So if you look at this, the green graph here now tells us the sign of the derivative. So over here in this area, before you get to 1, the derivative is negative. Between -1 and 0, in here, the derivative has a positive value. Then between 0 and 1, in here, the derivative is negative. Then over here, the derivative is positive. So our function looks like this. It's going down, then up, then down, and then up. So the shape of this, if I were to come through here, well, let's go back and look at one thing. The derivative is undefined at 0. So I'm going to put a u here for undefined. I'll do it in green. And then here the derivative is 0, and here the derivative is 0. So what that tells us is the graph. It goes down and up. Let me make this a little smaller. The graph goes down and up. And since the derivative is undefined here, it's got a sharp corner there. So the derivative tells us the shape of the graph. And if I make the original graph visible again, you can see it. So the derivative tells us that. And we could write out the intervals of concavity as being, the intervals of increase and decrease. This thing is increasing on -1 to 0, and from 1 to infinity, and it's decreasing on the places where the derivative is negative, from -infinity to -1, and from 0 to 1. All right.